Hello everyone, my name is Xiaotao Zhong. I'm the product manager for EMI products in Laird. Today, I'd like to talk to you about selecting the right solution for stray EMI. If you listened to the previous session done by my colleagues from Laird, you probably will know the key problems Laird can help you to solve really is around anything about heat or heat dissipation, or anything about EMI. And basically, we are offering various products like metal shielding products, MCP absorbers, and the EMI gaskets. And today's talk really is around EMI gaskets. So let's find out what kind of EMI gas solution we can provide from Laird. This is the agenda for today's talk. So we're going to have an overview about EMI Gasket products, and that will include FIP products and ECE FIP products. And what are they? Okay, let's find out in the next 45 minutes. So on the EMI Gasket product lines, we really have two types of gaskets you can choose. One is called Conductive Elastomer. Another one is called FOF. And under Conductive Elastomer, we have two subgroups. One is called ECE, Electrical Conductive Elastomer, and another one is called FIP, Form in Place Gasket. And the biggest difference between these two are really is FIP need a technique called dispensing to form a gasket and cool at customer place to form a really proper gasket product. And for ECE, it is something you will receive as a gasket already. Then you install it in the groove you have at your side. Yes, it needs tooling for us to produce this kind of product. However, for FIP, you don't need any tooling for any gasket formation. And on the FOF, we have three different types: fabric over foam, conductive foam, and conductive tape. And each of them can be formed by the die cut techniques. And you have various options of these product lines or families for different applications. I will quickly cover them in the next few slides. For Laird FOF gaskets, as I mentioned, there are three different types. So we were going to talk about them one by one. First of all, fabric over foam. It is a very traditional product lines from Laird, and we are always targeting to produce the product which is halogen-free and RoHS REACH compliant. And within the product lines, there are products rated at UL94V0 for flammability. And FOF product offers very good shielding effectiveness with very low compression force and excellent compression set. And currently, we are offering products with a temperature range or operating temperature range from -40 to 125 degrees C. And last but not least, we are offering SMD grades, which is compatible with SMT reflow process. So on this page, if you look at the diagram on the top left, it gives you a basic idea how the fabric over foam gasket look like. So by the name, really, it is a foam inside and wrap around with a metallized fabric. And in between, the hot melt adhesive helps bond them together. And you can choose either with or without a pressure-sensitive adhesive to help with the mounting. And on the diagram in the middle, actually, it is a material selection guide for you to choose what kind of material or what kind of fabric foam options for any FOF gasket. And the clue behind this diagram really, if you don't have any choice in mind, then start with 775. That's a standard product you can choose from Laird family. Or you can start with 51H if frame retardancy is needed. And beyond that, there are 4 different aspects you can go with. You can go with either high temperature or different color, like black, or different softness or hardness you can have for the gasket. And the last one really is we do offer some specialty products. Let me take you through with an example there. Say you start with 51H. That's a standard frame retarded FOF gasket you can have. If you're not happy with the temperature rating, or you are really looking at a higher temperature environment or higher temperature application, say 125 degrees C, then 617 probably is a better choice. And if you don't happy with about color, and you like to have something in black, then 618 will be the choice. Okay, and if you don't happy with the softness of about 618, then go for 619. So that's basically how you actually use this diagram for choosing the different material of a FOF gasket. And for specialty products, if you look at the top left of this diagram, you can have any gold-plated wrapped FOF gasket as well, just as an example. And for each FOF gasket type, if you like, you can always get this curve, which I have shown you on the top right. It's called FDR curve, or force displacement resistance curve. And the example I give you there is a typical FDR curve for 51H. And on this curve, you will see 2 curves plotted on there. One is resistance. So the higher the compression, the lower the resistance. Secondly, it is the force. The higher the compression, the higher the force. And somehow the 2 curves were crossed at some point. In this case, it's about 20% compression. And in that way, you can work out the working range for this type of gasket. And this information will be really helpful for the design engineer at the customer side. And in Laird, we can provide all the FDR curve for each type of FOF gasket. And we haven't touched about the profile of FOF gasket yet, but if you look at the picture on the top middle, that's the different profile you can have for our FOF product lines. And if you talk about what kind of application or what kind of market of this type of product has been supplied to, really, we're looking at the consumer devices, telecom, datacom equipment, and also industrial equipment as well. And on the FOF product lines, we also have something called Soft SMD Contacts. This is kind of product leveraging the existing FOF techniques and to form a product which is SMT process compatible. And currently we are offering 2 temperature rated products, which are 85 degrees C and 125 degrees C product. For 85 degrees C category, we have SLG, which is a rectangular profile, and also we have SLH, which is hourglass shape. And for 125 degrees C category, you have SLM, which is rectangular, and for SSM, that's the product you can have for any customized requirements, for any height and profiles. And if you look at the picture on the bottom right, That's a typical profile you can have, which I covered early on. Rectangular and hourglass shape. And really, for this type of product, you can have anything up to 125 degrees C, which is a typical application temperature for automotive industry. And because it is a good leverage of existing FOF techniques, so this kind of soft SMD contacts has got very low compression force with very good compression set. And currently, from flammability perspective, we have product which can rate it up to UL24 V1. And at the moment, for standard products, we only offer from 3 millimeters to 10 millimeters for height. And in order to accommodating the automation process at the customer end, we are offering a tape reel packaging for any automated process. Again, it is a SMD grades, so it is compatible with any existing SMT referral process. So you don't need to modify any process for using or applying this kind of contact, soft contacts. Like what we have for FOF, this kind of product is widely used in the consumer device market, and also we've seen good amount of application from automotive market as well. On this page, we will quickly cover conductive foam. The picture on the top left and also the schematic diagram underneath it, that gives you a quick idea about how the conductive foam looks like. And really, by offering conductive foam, you will be able to achieve the conductivity for all around, or from X, Y, and Z axis. If you don't have any preference in your mind, then start with CF500. Again, if frame retardancy is something you have to have, then choose CF700. And we do offer anything in black, that's CF600 and CF800. As I mentioned, for conductive foam, it's a very compact solution for achieving really EMI shielding and grounding with its all-round conductivity. And just like what we discussed for FOF products, we offering FDR curve for our design engineers for each type of conductive foam. Again, the key markets for this type of product is really the consumer device. I have some good examples for you in the next some slides. Okay, for conductive tape, we do offering one side and double side conductive tape by leveraging the existing conductive fabric techniques, especially for any application which has got space constraint. And one thing or one type of tape I like to highlight there is 87580. That's the only product we have UL rating. Okay, let's quickly have some examples there. So for FOF products, again, FOF products itself is a very good EMI shielding material, and very often it can be used as for grounding application as well. If you look at the example I give you on the left, that's actually as a laptop application. And if you look at the blue circle there, you will see pre-cut piece of FOF gasket there for grounding applications. If you look at the example in the middle, again, it is a die-cut FOF gasket. By having this type of gasket between the metallic housing and the PCB board, where the connector is, it gives a very good grounding function, and also it fills the gap between the housing and the connectors, which gives a good EML shielding overall. to achieve the EMC compliance requirement. And if you look at example on the right, actually it is a telecom cabinet. And where actually the door is, you will have a series of fabric over foam gasket there to fill in the gap between the door and the frame and achieve a EMI shielding function. And on this page, you will see a good example of soft SMD contacts. And in the blue box there, you will see 3 pieces of soft SMD in the notebook application. And as I mentioned earlier on, this type of soft SMD is fully compatible with any SMT refill process. And you do need to spend extra or modify any process to accommodate this kind of SMD device. And really, SMD there to have a very good grounding function to help protect any electronic components on the PCB board. And on this page, there are examples of layered conductive foam. And as I mentioned earlier on, really, if you have any space constraint in the structure design, and you can't really fit in any FOF gasket, then consider conductive foam. It offers the smallest thickness of any foam type of gasket. And it has got very good grounding function there to protect any electrical components in the notebook application as we see on the screen. On this page, I'd like to quickly show you a new product we call Flex G Gasket. If you look at the picture on the top right, that's how the product looks like. And really, the product itself is a good leverage of existing FOF techniques or FOF materials, but with a very novel design. And if you look at the picture on the bottom right, that's how it applies to the metallic housing for any grounding applications. And we do some quick comparison between the traditional metal fingertip stock, traditional FOF gasket, and the Flex G gasket. And what we found there, really, it is a very good shielding material, as effective as two traditional material or traditional component products. However, it offers much lower compression force, even lower than FOF gasket, because of this innovation design or profile. And Laird has patent for this type of products. And we've seen more and more consumer device like gaming consoles manufacturers start to use this type of products for their for their device for any grounding applications. Next on, we will talk about layered conductive elastomer gasket. And there we will be covering 2 types of gasket, ECE and FIP. Before we actually jump into each individual, let's have a quick look at what is a conductive elastomer. And by the name, really, it is kind of solid elastomer which contains dispersed particle of conductive materials. If you look at the diagram on the screen, the gray particle or gray circle, that's the conductive fillers, and the white bit really is the polymer matrix. So it is something to be electrically conductive through use this metal filler, which is embedded in the base polymer matrix. And that's how it works. when it is compressed. It forms a conductive path, and the electron go through the path which formed by the conductive fillers. And for the polymer matrix, currently you can choose silicon, fluorosilicon, and EPDM. If you look at the product on ECE product or conductive elastomer product on the market. And typical filler you can have is something like silver-coated nickel, silver-coated copper, silver-coated aluminum, pure silver, and nickel-coated graphite. And the diagram on the bottom right, that gives you a basic idea what is the size of this kind of particle. It is an example of silver aluminum. The average particle size in diameter is around about 60 micron, and the silver coating outside is about 1.5 micron thick. Okay. Now we move on to FIP gasket. So as part of the conductive elastomer offering, FIP really has got various filler options for you. And we are currently offering two grades there called room temperature curable and high temperature curable. And for this type of gasket, we are talking about typical compression range from 10 to 50%. And currently, we can offer two profiles as well, triangular and D shape. And for some grades, we are offering small bead for any miniature application. And typically for FIP, it has got very secure bonding between the gasket itself and various substrates like metal, plastic, etc. And currently for Laird, the key market there is for telecom, datacom applications and automotive. On this page, that gives you some quick idea what type of or what kind of FIP gasket you can choose. And actually, for FIP, we are offering both non-conductive and conductive. For the conductive family, you can choose 4 different fillers: silver copper, silver aluminum, silver nickel, and nickel graphite. And you do have different choice of hardness as well. And basically that forms the product offering or products you can have as FIP from Laird. For example, if you choose anything silver nickel, then you start with the part name will start with SNN. And if you're looking for something with show a hardness 55, and also it can be cooled by heat, then SN55 HXP. That's the grade you could have. And for a typical grade of FIP, we are offering 3 different packagings: 55 cc, 300 cc, and 3 kilos bucket. And one more thing I'd like to highlight there, for SN55 HXP grades, we do have some small bead application or small bead grade available of this family, which I have example to cover in the next slides. And in nickel graphite type of FIP, we do see a good trend of going from going for some soft grades, and I have some good example to cover that as well. Okay, so for soft nickel graphite FIP, as I mentioned, we're offering 2 different profiles, traditional D shape, and currently we are looking at triangular shape. And I have a quick video there to show how actually the gasket or the FIP paste can be dispensed and form a gasket. it is a pre-programmed procedure or process, and the dispense machine actually go with a preset program and along the aluminum die casting part. And by doing that, the FIP gasket dispense and form where it need to be. And after that, it will go through a curing process. In this case, it will be cured by heat or at high temperature. And if you look at the difference between the traditional deep profile and the triangular profile, really, it is something talking about material saving. By having the triangular profile, we are talking about 10 to 15% lower for material usage. That means a cost saving for the customer. And if you look at the video carefully, it is quite efficient process as well. That really is driven by another feature for this type of gasket. That's the high flow rate. And we also looking at the soft feature for this type of product as well. That really is something to do with the compression force. The lower the compression force, the lower the enclosure force for the application at the customer end. And overall, well, that will trigger some cost and weight saving for any big telecom equipment. And the biggest advantage for this type of triangular profile from Laird is really that it can be achieved in one step. So that gives you less hassle for applying this kind of products compared to other products you can have off the market. Again, overall, it means cost saving for our customer. On this slide, really, I'd like to show you a quick example of our small bead SN55 FIP application. The picture you look at on there, it gives you a good example of the optical transceiver module. And the FIP gasket will be applied on the die-casted housing as a EMI shielding gasket. And this product typically is talking about miniature structure. That means you don't have very much room or only small bead gasket needed or required for those kind of structure design. So for having with this kind of small bead FIP, you were able to achieve a gasket which is below 0.5 millimeter. Something around 0.4 millimeter, and also itself has got low hardness, which is around 55 for short A. Again, that's a good advantage for achieving lower encroachment force overall for this kind of module. Okay, next we like to talk about ECE, or electrical conductive elastomer. Like what we have for FIP, for ECE, you can have even broader selection for polymer and fillers. And the typical compression range we are talking about for this type of gasket, again, is about 10 to 15%. And this is a preformed gasket in Laird by having different profiles or extruded profile, if you like. And also, we are offering any molded or pre-die cut gasket as well for ECE. And the typical operating temperature for this type of gasket is around -55 to 150. The key markets we are looking at really is telecom, datacom, automotive, and again, aerospace and defense. On this page, that gives you a quick idea about what kind of extruded products you can have as a EMI gasket. So if you look at the top left, that's kind of extruded profile you can have. There are two major types, one solid and hollow gasket. So if you're talking about any low enclosure force for same conductive material or conductive elastomer, if you want anything has got lower compression force or enclosure force, go with any hollow design, either hollow D or hollow O. Both are very popular with our design engineer at the customer end. If you look at the profile next to them, and it is really a hybrid gasket, if you like. So the shaded bit is the conductive elastomer, and the rest of it are non-conductive elastomer. By having those two together, really to achieve both environment sealing and EMI shielding, but at a lower cost. And if you look at the picture on the right-hand side, you will see some good example of the hollow profiles and the co-extruded profile as well for this kind of non-conductive elastomer and conductive elastomer combination. As I mentioned, the gasket you choose has to be a good fit for the groove in your design. So a 95% filling for the groove is recommended for both EMI shielding and environment sealing. And it has to be compressed to achieve any EMI shielding, if you like. So we are talking about 10% as a minimum to start with. So anything above 10% and anything below 50%, that's kind of operation range we would like to recommend for this type of extruded gasket. On this page is some examples of our molded gasket for you. And on the left-hand side, it is 100% molded ECE products. And you will see some very complicated design, or like a sharp edge, some gaps, some steps for the different profile. That's really a good demonstration of Laird's molding techniques. That means by having this kind of techniques, that gives you some flexibility to have a EMI gasket to accommodate any complex configuration or structure design at customer end. On the right-hand side, there are some examples of some specialty products. So we're talking about extruded profile. We just covered the molded profile or molded gasket. So the example on the top right, that's a combination of extruded product and the molded product as a whole. By combining these two types of gasket there, we have some product called cable gland formed for some typical telecom, datacom application for both environment sealing and EMI shielding. On this page really is a good demonstration for you to see how broad ECE choice or grades you can have from Laird. And I'm not going to cover each of them. And basically, we will be offering all sorts of different matrix with all sorts of different fillers for different application, either military or non-military. And more importantly, what we're seeing really is the ECE material has gone soft, and in some cases, low volatile is also needed for some applications. So I have got some example for you in the next on slides. Okay, so on this slide, for the molded product, a molded ECE product, we are really talking about something has got Shorn hardness around 65 to 75. And that's a traditional or typical ECE you can have off the market. And now In Laird, we're also looking at some soft ECE, which has got shown hardness as around 50 or below 50, just below 50. In parallel, we're also looking at some ultra soft ECE product as well, or material as well, which has got showing hardness around 30. And by having that means we were able to tuning the hardness of ECE, molded ECE products, just like what we do for any non-conductive elastomers. And on the right-hand side, I have got some example for you. It is the FDR curve, like what we discussed for FOF gasket. We apply the same principle for ECE gasket as well. So I have two samples there, or two products there. The traditional 93, ECE 93, which is a nickel graphite grade. You can have the resistance versus compression and the force versus compression in the black curves. And you can have the FDR curves for this novel ECE in red. And you can see really this novel soft ECE offers very low compression force or lower incursion force for applications and higher interface resistance over different compression range. Okay, so on this page, it's really a good example I'd like to give you about this soft ECE. If you look at the diagram on the top right, actually it is an optical transceiver module again. And where the TOSA-ROSA area is, we've seen a good typical application for our ECE gasket. Again, it is a good environment sealing product, and also that gives the EMI shielding as well to help protect the TOSA-ROSA area from cross-talking. And the picture in the middle, that's how one of the design, how the ECE gasket look like around the TOSA-ROSA area. And if you look at the picture on the bottom left, that's also different gasket we have designed for different optical transceiver module manufacturers. If you look at the feature of this product, first of all, it can be moldable. That means you can have a different design for the profile, or it can be customized for different structure or different design at the customer end. Secondly, it is soft material. Again, that means a very enclosure force and less dispersed to the component next to it, and no damage to any fragile or expensive optical components within the module. And the last one here is I list out here is low volatile. This kind of material also has got low volatile content during the operation. As you may know, there is a good trend for this kind of module going for very high speed. And in the meantime, it goes smaller or more compact. So the heat during the service or the heat dissipation become a challenge. And for polymeric material in this kind of system can give out any volatile or any VOC during the service while more heat or higher temperature environment. So by having this kind of low volatile property or performance, that's really an advantage of minimizing the contamination to the components within the module, especially for the optical ones. Okay, so we have gone through two different types of gasket, FOF, conductive elastomer, and for each of them we have go through different subgroups. And here I have a summary page for you. So really, how to choose? Both of them are EMI gasket, and how to choose which one will be the better solution or better option for you, you really can look into them by two different aspects. So if you look at on the right-hand side, if the compression force is the key or the key thing you look at, and you want something has a lower compression force, then go for F4F. However, if anything to do with the environment sealing, which is the key problem you have in your system or in your design, and the conductive elastomer will be a much better choice for you. So hopefully that will be a really something you find useful with for you for choosing any EMI gasket product in Laird, and really thank you very much for your listening.